Okay, 9.2, L'Hopital rule. Next year, Calculus A, B will also have to know this rule, so I'll have to teach it. L'Hopital. L'Hopital. Okay, suppose that f of a equals g of a equals 0. That f prime of a and g prime of a exists. And that g prime of a does not equal 0. The limit of f of x over g of x as x approaches a is equal to f prime of a over g prime of a. So, we did limits a long time ago. We did limits in chapter 2, and what we are doing today is that we're going to revisit limits. And I'm just going to go back and give you a limit from chapter 2. So let's just review chapter 2 limits. And I'm just going to kind of make up a couple. What is the limit as x approaches 2 of x squared plus 3? Okay, all you do is, what is the limit? Remember, the limit is the y value, and all you're going to do is you're going to plug 2, or substitute 2 in. 2 squared is 4, and 4 plus 3 is 7. If you graphed x squared plus 3, and you looked at the y value, at x equals 2, I'm sure the y value is going to say 7. Okay, one more. The limit as x approaches 1, and it's x squared minus 1 over x minus 1. Okay, this one's a little bit harder. In the first one, you could just substitute 2 in and get 7, but in this one, when you substitute 1 in, you're going to have 0 in the denominator. So, what you learned in chapter 2 is to factor x minus 1, x plus 1 all over x minus 1. And these are going to cancel out. When you substitute 1 in, you're going to get the limit now is 2. Okay. Other than that, those are how you did your limits. I know you did one-sided limits and two-sided limits or whatever. But now I'm going to show you another problem using L'Hopital's rule. And here's problem number 1. Basically, all I'm giving you is a bunch of examples using L'Hopital's rule. The limit as x approaches 0 of the square root of 1 plus x minus 1 all over x. Okay, as you can see, these problems got harder from chapter 2. If you substitute 0 in, you cannot have 0 in the denominator. You can't factor it, so what are you going to do? So you're going to use L'Hopital's rule, and basically, this is L'Hopital's rule. I'm just going to tell you right here, and this is going to make it way easier than the way they just wrote this. Basically, if you can't put the limit in, and it turns out to be 0, what you are doing is you're basically taking the derivative of the numerator and the denominator. That's what L'Hopital rule is. So, here we go. It's not working right now. So you're gonna redo it, and you're gonna do, this is the same thing as 1 plus x raised to the 1/2 power. So I'm gonna take the derivative of that, which is 1/2, 1 plus x raised to the negative 1/2 power. You don't have to do the inside, which is 1. The negative 1 drops off over 1, which makes 1, the 2 goes in the denominator, And 1 plus x to the negative 1/2 is the same thing as 1 plus x. By taking the derivative of the numerator and the denominator, now I can do the limit as x approaches 0. When I put 0 in, I get the square root of 1, which is 1. I'm going to get 1 for my answer. L'Hopital's rule is basically taking the derivative of the top and the derivative of the bottom if it turns out to be 0 in the denominator. I want to go back to chapter 2 again, and you're going to say, aha! So, problem number 1 was easy, but problem number 2 didn't work, correct? So we learned how to factor it in chapter 2. Let's use L'Hopital's rule. The limit as x approaches 1, and L'Hopital's rule says to take the derivative of the top, which is 2x, the derivative of the bottom, which is 1. Now, you no longer will get 0 in the denominator. You substitute the 1 in, and guess what you get for your answer? Aha! Interesting. Okay, let's do some more. Number 2. Basically, all I'm going to do is show you some harder problems, and I've got a lot of them to kind of show you. But if you see the limit as x approaches 0 of 1 minus the cosine of x over x plus x squared. Again, as you can see, when you substitute 0 in, it doesn't work. You can't even factor this. It's pretty hard to factor a trig function and an algebraic function. All I'm going to do is take the derivative of 1, which is gone. What's the derivative of a negative cosine? A negative cosine is going to give you a positive sign all over 1 plus 2x. And what I should do now is, well, I can just leave it. What is the derivative, or when you plug 0 in there, you get the sign of 0, and the sign of 0 is 0. I'm just going to show you right here. The sign is the y value, it's 0, and 1 plus 0 is 1, so the answer is 0. Okay, next part. What is the stronger form of L'Hopital's rule? The stronger form of L'Hopital's rule is to keep taking the derivative. Find the derivative twice. So find the double derivative. So here's an example. Example 3. The limit as x approaches 0 of the square root of 1 plus x minus 1 minus x over 2 divided by x squared. Okay, so we find the limit as x approaches 0. The derivative of this is 1/2, 1 plus x to the negative 1/2. The negative 1 drops off. This is a negative 1/2 divided by 2x. Okay. Obviously, when you substitute 0 in, you still get 0 in the denominator. So you got to do it again. Find the derivative again, the limit. As x approaches 0, what's the derivative of 2x? 2. What's the derivative of 1/2? It's gone. What's the derivative of this? You take the negative 1/2, you put it out in front, which gives you a negative 1/4. Leave the inside alone. Subtract 1 from it, which is a negative 3/2. Also find the derivative of the inside, which you are done. Okay, I'm going to simplify this. This is the limit as x approaches 0. This can come down and join the 2, so it's really a negative 1/8. This can also come down, and it's going to end up being the square root of 1 plus x raised to the third power. When I plug 0 in, 1 plus 0 is 0. 1 plus 0 is 1, the square root of 1 is 1. You're left with a negative 1/8 as your final answer. Okay, one more, just to show you that maybe this one isn't going to be exactly perfect. If you see the limit as x approaches 0 from the right of the sine of x over x squared, this is going to equal the cosine of x over 2x. And when you plug 0 in from the right, you could do it again. Its cosine is going to end up being a negative sine of x over 2. And as x is approaching 0 from the right, I'm just going to graph it to see what it looks like. So just give me 2 minutes to graph this. I'm going to graph, let's see. I'm going to graph the cosine of 2x, or the cosine of x first, divided by 2x. I don't know why I'm graphing this one, but graph it. And as x is getting closer and closer to 1 from the right, it's getting closer and closer and closer to, as you're approaching 0 from the right, it is getting closer and closer and closer to, okay, getting closer and closer to infinity. Sometimes it works better if you just graph it like number 4 without doing L'Hopital's rule. I'm going to show you some different ones. Number 5, the limit as x approaches pi over 2, secant of x over 1 plus tangent of x. If you know what a tangent graph looks like, I'm just going to tell you that the tangent at pi over 2, which is 0, 1, is y over x, which is 1 over 0, which is undefined. So I'm going to take the derivative of secant, which is secant of x, tangent of x. The derivative of 1 is gone. The derivative of tangent is secant squared x. Here comes the trigonometry now. They both have a secant, so I'm going to cancel one out. Tangent is sine of x over cosine of x. Tangent is sine over cosine. And then this is really 1 over cosine. So when you flip it, it's cosine over 1, which ends up just being the sine of x. Okay, we still need to plug, as x is approaching pi over 2, as x is approaching pi over 2, which the sine equals 1. So these are just different problems using L'Hopital's. I'm going to give you one more. I don't know how many more I'm going to do. The limit as x approaches infinity, as x keeps getting bigger, the natural log of x over 2 squared of x. I take the derivative of the natural log of x. Remember, it's the original over, or the derivative over the original, 1 over x. The derivative of 2 squared of x is, remember that this is 2x to the 1 half. I bring the 1 half, it's x to the negative 1 half, which ends up being 1 over x, and this is 1 over the square root of x, which ends up being the square root of x over 1. Which equals 1 over the square root of x. This is made up of the square root of x times the square root of x, so you can cancel out, and this cancels out. And as x is getting bigger and bigger and bigger and bigger, think about the numbers as x keeps getting bigger and bigger, like 500, 1,000. Isn't it getting closer and closer and closer to 0? I think that is plenty. I have one really long one. I don't think I'm gonna do it. It's fine, I think you get the idea that if, the first time you do the derivative for L'Hopital's, if it doesn't work, do the second derivative, simplify it.